Okay. So I'm going to consider the next problem, problem number 3. Same as usual. Consider the below data set. Apply the algorithm to generate the partial space. So now I'm going to write the data set. Record ಆಗ್ತಾಯಿದೆಯಲ್ಲ?
Yes, sir. ಆಗ್ತಿದೆ.
Okay. Sorry. Okay. Okay. The first chart. This is important for your exam point of view. Okay. So this data set ಸುಮಾರು ಸಲ exam ಕೇಳ್ತಾ ಇರ್ತಾರೆ. The first attribute is sky, air temperature, humidity, wind, water, forecast, target. So this data set is very important for your exam point of view. Okay, so please go through this data set. Okay, the first attribute value is sunny, warm, humidity, normal, strong, warm, forecast, same, target is yes. Warm, the first one is cold. Next is same, change. So this one is change. This one is no. So this is your data set. So I need to generate the solution, many solution by using the CE algorithm. Let me check once. The attribute values are whether it's correct or not. Warm, cold, warm, normal, high, and all are strong. Warm, cold, same, change. Yes, no, yes. Okay. So for your exam point of view, so please go through this data set. Okay. So this is very, very important one. So as usual, I have explained to you in the last class, the very first step is, first step is we had to initialize the specific boundary as well as the general boundary. Initialize the specific and the general boundary. So this is the first step. So now I'm going to initialize the specific boundary. The specific boundary is represented by S naught. So now initially this data set contains 6 attributes. Therefore, null 1, null 2, null 3, null 4, 5 and 6. Similarly, at the parallelly, we have to initialize the general boundary that is represented as G naught. G naught is equal to, since the general boundary means we need to accept all the attribute values. That's why it is question mark 3 plus 2, 5. So all are question mark. Since we have here we have got totally 6 attributes. That's why 6 question mark and as well as same for the specific boundary. So as I have explained to you in the last class only, first we have to take the first instance x1. We need to apply this x1 to this specific boundary and we need to apply x1 to the general boundary. In the specific boundary, we have to apply finder's algorithm. Whereas in the general boundary, we have to check for the consistency. If it is consistent, you keep it. If it is inconsistent, we have to apply negation operation. So based on the negation operations and all, we have to work on this algorithm. So now, oh, 1 second. Okay. So here the positive, this specific boundary grows from top to down, whereas the general boundary grows from bottom to top. So every time our agenda is to see whether it is consistent or not. That is our agenda. So let us apply the first instance to the specific boundary. So as I explained to you in the last class, the specific boundary, for the specific boundary, we have to apply finder's algorithm. Since the first instance is positive, correct? So this instance is positive. Therefore, I'm going to copy as it is to the specific boundary. It contains what? It contains Sunny. Sir, class ಅಲ್ಲಿ ಇದೀನಿ ಸರ್. ಹಾಂ ಸರ್. ಆಯ್ತು ಸರ್, ಮಾಡ್ತೀನಿ ಸರ್. ಆಗುತ್ತೆ ಸರ್, ಆಗುತ್ತೆ ಸರ್. ಓಕೆ ಸರ್. ಹಾಂ ಸರ್, ಓಕೆ ಸರ್. ಹಾಂ, ಬಿಡ್ತೀನಿ ಸರ್. ಓಕೆ ಸರ್. ಹಾಂ, ಓಕೆ. So next is varam, next is normal, next is strong, varam and same. So this is the specific boundary. So now we have to do the same thing, same operation to the general boundary. So as I explained to you in the last class, so here I'm going to write. This is for your rough work, okay? ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರೀಬೇಕು ಅಂತ ಏನಿಲ್ಲ. This is for your rough work ಅಷ್ಟೇ. ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಲಿಕ್ಕೋಸ್ಕರ ಬರಿತಾ ಇದ್ದೀನಿ. You can write straight away, but you need some sort of practice ಅಷ್ಟೇ. So G naught. So it contains all our question mark. 3 plus 2, 6. Okay. So now I'm going to give the first instance as input, that is x1. So it clearly says x1 is a positive instance. The moment I give this instance as an input, I have to see what is the output of G naught. So what is the output of G naught here? Since it contains all our question mark, therefore output of each question mark is 1, because question mark indicates general boundary, accept all the attribute values. So this will gives you 1, which indicates what? Which indicates positive. So now this incoming instance and the G0 classifies X1 as positive. So therefore, to classify X1, G0 is sufficient for me. So no need to update the general boundary. I'll keep that hypothesis as it is. The moment I give X1 as input to the version space, my boundary is updated to G1. My boundary is updated to G1. Since to classify G0 has consistently classifies X1 correctly, therefore G0 is enough for me. So next I'm going to give the second instance as an input, that is X2. So as I explained to you, we need to apply X2 to this specific boundary, X2 to the general boundary. So let us apply S2, X2 to the specific boundary. Now, if you apply the next instance, the specific boundary is slowly growing towards the bottom side. So as I explained to you, we need to apply finder's algorithm. In X2, we have the attribute value, that is Sunny. Here also Sunny. Sunny multiplied by Sunny is Sunny only, because A into A is A. So now, next Varam into Varam is Varam. So next we have high is there, here normal is there. So there is a mismatch in the attribute values, correct? Normal and high. Since there is a mismatch in the attribute values, we have to generalize it by making it as a question mark. Next Varam, last one is same as it is. So now we have to give, after giving the instance x2 to the specific boundary, the same thing has to be repeated with the general boundary. So in this particular general boundary version space, we have which hypothesis? This hypothesis is present. We have to see whether this hypothesis understands x2 correctly or not. So therefore, what I will do, I will give that input to this hypothesis in the general boundary version space, which is a positive. So when I give this x2 in the general boundary contains all our question mark. Because of this, output of each attribute values will becomes 1. Therefore, G0 classifies x2 as positive. Therefore, G0 understands what is x2. Therefore, to classify x2, this hypothesis is sufficient. So therefore, to classify the next instance G2, X2, G1 is sufficient, or G0 is sufficient. Both are same. So next I will consider the negative instance. So now this is your negative instance. The moment I get the negative instance, I will make a mark. So after marking the up to from x1 to x3, so now we have to check for the consistency starting from x1 to x3. That is the concept. So now what I will do, I will give this x3 input to the specific boundary. Let us see this x3 is a negative instance. Let us check whether x3 correctly classifies by specific boundary or not. Let us check that. So now I will give that x3 to the specific boundary, then it is updated to s3. So let you can see here the specific boundary, we have this hypothesis. So rainy is there, here sunny is there. So because of mismatch, what you will get? Because of mismatch, you will get 0. All right, here x3 is there, which is a negative instance. So now I'm giving this x3 to the hypothesis, that is S2. What S2 contains? S2 contains sunny, Varam, question mark, strong, and Varam and same. I don't have space here, so please try to understand. Okay. Okay. So now I will give this input to here, and similarly this input, and see what is the output of S2. So it's clearly says here it is rainy is there, here sunny is there, so there is a mismatch. So because of mismatch, what you will get? 0. So 0 multiplied by anything is obviously it is 0, which is negative only. So therefore it clearly says that S2 is consistent with X3 because X3 is a negative. S2 saying X3 is a negative. Both input and output are same. Therefore, I'm not going to update this S2. I'll keep S2 as it is. So now, since S2 classifies X3 correctly, I'll keep S2 as it is. So now I will give that instance to the general boundary. Let us see what happens. When I give that instance to the general boundary, since X3 is a negative instance, since in the general boundary all are question mark, since because of question mark, output of each question mark will be 1 1 1, therefore after multiplying you will get positive. But don't you think it is inconsistent? Because incoming is negative but G naught is saying positive, so minus and plus, which are not same, therefore it is not good. We need to do some operation. That operation is what? Negation operation with the general boundary. So I explained to you in the many times how to apply negation. So let us apply negation to each and every attribute values. So before that I will clear all these things. Okay. So now you got G3. So let us apply negation. So now please look at here in the negative instance, since we are working with X3 right now, rainy is the opposite of rainy is, you need to write sunny. And remaining all are question mark. So this is over. Next, cold is the opposite of cold is warm. And remaining all the attribute values are question mark. Next, high is there, opposite of high is normal, and remaining all the attributes are question mark. Next, strong is there, 1 2 3. Opposite of strong is not available there, so I'll write strong as it is. Next to warm is there, so opposite of warm is cold is available there. Cold, comma, question mark. And the last one, opposite of change is there in X3 instance, correct? Here in X3 change is there, opposite of change is same, we need to write. That is question mark, 2, 3, 4, 5, and 6, same. Okay. So let me line something else. Okay. So now after applying negation, since I have marked the negative instance, so now we have to check from the first instance till to the marked instance, correct? The marked instance is, okay. So here this is the marked instance. So now I have to check whether these negated hypotheses are consistent with all the three hypotheses starting from x1 to x2. We have to check it out. So how to check that? That I have already explained to you. It's straightforward. So first I will consider positive instance. So here sunny is there. So here also sunny is there. So 1 multiplied by 1, because of same attribute value, you will get 1. So 1 multiplied by 1 is 1. Output of this instance is 1. Yes, it has understood the first instance correctly. The second instance contains sunny. Here also sunny. Same attribute value, and these all are question mark. So because of that, 1 multiplied by anything is 1. Yes. Next, rainy is there. Here sunny is there. So there is a mismatch. So because of mismatch, what you will get? You will get 0. 0 multiplied by anything is 0. So now please look at here. S is a positive instance. This is a positive instance. This is a negative instance. 1 stands for positive. This stands for positive. 0 stands for negative. So plus plus minus is the data set. My hypothesis is saying plus plus minus. Therefore, this is consistent with all these three hypotheses, x1, x2 and x3. Therefore, I need this hypothesis for the next step. Therefore, I need this hypothesis for the next step. Similarly, I'll consider the next hypothesis, Varam. Let us say this is consistent or not. I'll give x1 as an input. Varam is there. Here, Varam is there. So both are same. 1 multiplied by anything is 1. So this is a positive instance. My hypothesis is also saying positive instance. Let us give the second one, Varam. Here also Varam is there. 1 multiplied by anything is 1. It is saying positive. Incoming is also positive. Next, cold is there. Here Varam is there. So there is a mismatch. Because of mismatch, what you will get? You will get 0. 0 multiplied by anything is 0 minus. Incoming is also minus. So plus plus minus, plus plus minus. Yes, this hypothesis has understood these three instances x1, x2 and x3. Therefore, I need this hypothesis for the next step. Therefore, I need this hypothesis for the next step. Next, I will consider normal. So here also normal is there. Here normal is there. There is same attribute value. 1 multiplied by anything is 1, which is a positive attribute, and this is also positive attribute. Next, high is there. Here normal is there. So please look at here, high, normal. There is a mismatch. Because of mismatch, what you will get? 0. 0 multiplied by anything is 0. 0 stands for what? Negative. But here S is there, positive. So plus minus inconsistent. Therefore, this is misclassifying the instances. Therefore, I don't want this hypothesis. Since it has misclassifies the instance x2, therefore I do not, oh, one second, I do not want this hypothesis. Let us check for the next hypothesis. Here strong is there, here also strong is there. There is a same attribute value. 1 multiplied by anything is 1, which is a positive. This is also positive. Next strong is there, here also strong is there. Same attribute value, positive. This is also positive. Next, strong is there. Here also strong is there. Same attribute value. You will get 1. 1 multiplied by anything is 1, which is a positive. But here no is there, which is a negative. The data set is saying plus plus minus, but you got all are pluses. It clearly says it has not understood the last instance x3. Therefore, it is, I don't want this hypothesis. Let us remove that hypothesis from the question space. Let us remove this hypothesis from the question space. Next, we'll go for the next attribute value, that is cold. So here Varam is there, here cold is there. So because of mismatch in the values, straight away you got 0. So but this is positive. My hypothesis is saying negative. Straight away you can reject this hypothesis as it has misclassified the first instance, that is x1. I don't want this hypothesis. Next, we will go for the last hypothesis. So here same is there. Here also same is there. Same attribute value will get 1. 1 multiplied by anything is 1, which is a positive. Incoming is also positive. Next one is same is there. Here also same is there. Both are same. 1 multiplied by anything 1, which is a positive. Yes is there, which is also a positive. Here change is there. Here same is there. So please change same. There is a mismatch in the attribute values. Therefore, because of mismatch, you will get 0. 0 multiplied by anything is what you will get? 0, which is a negative instance. In the data set also we have negative. So plus plus minus plus plus minus. Yes, this hypothesis understands all the three hypotheses x1, x2 and x3. We need this hypothesis for the next step. We need this hypothesis for the next step. Next step. Okay. So now we'll go for the next instance, that is x4. We'll consider x4 now. Let us apply x4 to the specific boundary. After that, we have to apply x4 to all these three needed hypotheses, to this one and to this one and to the last one. The middle three hypotheses we have to neglect because it has totally misclassifies all the instances. So let us apply this x4 to the specific boundary. The moment you apply x4, you will get the specific boundary is updated to s4. So it is a positive instance. x4 is a positive instance. Let us apply find S algorithm. So Sunny into Sunny is Sunny. Varam is there. Here also Varam is there. Question mark multiplied by anything is question mark. Strong, strong, both are same. Varam and cold is there, correct? Cold is there, Varam is there. So therefore, we need to accept both attributes, generalize it as per the find S algorithm. Change same is there, so question mark. So this is done. So now we have to, oh, I'm running out of time, okay? All of you, are you there? Hello?
Yes, sir.
I'm running out of time. ಮೂರುವರೆ ಮೂರು ಮುಕ್ಕಾಲಾಯ್ತು. ಓಕೆ, ಮತ್ತೆ ರೀಲಾಗಿನ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ರೀಲಾಗಿನ್ ಆಗಿ ಆಯ್ತಾ ಆಮೇಲೆ. ಓಕೆ, ಸೊ now we have to apply this instance x4 to the first one. Let us check whether it is consistent or not. Like that we need to repeat. It is very easy, as I explained in the last class, last videos and all. So when you apply x4, my instance is updated to my boundary has updated to g4. G4. Okay. So now let us straightforward. It is straightforward. Here Sunny is there. Here also Sunny is there. Both are same. 1 multiplied by 1 is 1, which is a positive. Incoming is also positive. Yes, my hypothesis, this hypothesis understands the last instance correctly. Therefore, I need this hypothesis in the next step. So therefore, since it has classified x1 correctly, therefore I'll update the general boundary to that hypothesis. Next, let us apply the same x4 instance to this second hypothesis. I'll change the color so that you will easy to notify it. Okay, otherwise I'll use this one. Okay. Okay. Yeah. Okay. Next here Varam is there. So here also Varam is there. So Varam into Varam, Varam, same attribute value 1. 1 multiplied by anything is 1. Incoming is positive. My hypothesis is saying positive. Yes, it has understood correctly. This hypothesis has understands correctly X4. Therefore, I need that hypothesis for the next step. Therefore, I need that hypothesis in the next step. That is question mark, varam, question mark, question mark, question mark, question mark. More. Okay. Next, the last one is same. So let us check whether it is classifies correctly or not. Here, change is there. Here, same is there. So straight away, change, same. There is a mismatch in the attribute values. You will get what? Because of mismatch, 0. 0 multiplied by anything is 0, which is a negative. But the incoming is a positive. So there is clearly says plus and minus inconsistent. Therefore, I don't want this hypothesis. So therefore, I have to update that hypothesis. So earlierly G3 was the needed, but the moment you give X4, it is misclassifying it. Therefore, I don't want that. Therefore, I don't want that hypothesis since it has misclassifies the instance X4. So finally, so all the instances of the data set we have read. Therefore, the final version space is this one. This is my final version space. So in the final version space, I have got the 3 solutions, 1, 2, and 3. So using these 3 solutions, I have to go for the step number 2. Here I will write step number 2. What is step number 2? We have to generate more hypotheses using the version space. So in order to generate the more version space, I have already explained to you. So first we have to, I will write the hypothesis which contains more number of attribute values. So in this version space, this is the hypothesis which contains more number of attribute values 1, 2, and 3. So this I'm going to write because it contains more number of attribute values. The first solution what you got is Sunny, Varam, question mark, strong, question mark, and question mark. Okay. So as I explained in the last class, we have to start from the length number 1. Length number 1. That means you have to keep only one attribute value and remaining all are question mark. So second hypothesis I will generate from this particular hypothesis. I'll keep only one attribute value out of 3 attribute values and remaining all are question mark. So therefore, I'll keep Sunny as it is and remaining all are question mark. Since Sunny is already, this attribute is already present in the final version space. Therefore, it is required in the second step. Next option, next possibility is, third possibility is, you keep the Varam as it is and remaining all are question mark. So again, this version space is already present in the final version space. So this is the final version space. Therefore, I need that in the second step. So now, fourth one. I'll keep strong and remaining all are question mark. Look at here. So this is the hypothesis I have written based on length number 1. But this hypothesis we have already neglected in the G3 space. Since it is giving wrong result in G3, therefore I cannot use this hypothesis as the final result in the second step. Therefore you cannot write the fourth hypothesis as a final result, as it is giving the wrong result. So next we'll go for the length number 2. So if you go for the length number 2, that means we have to keep only 2 attribute values, that is Sunny and Varam, and remaining all are question mark. So I think it is straightforward, since those hypotheses does not exist in this G3, therefore we can keep. And another possibility is I'll keep Varam question mark and strong, and remaining all are question mark. Another possibility. Next possibility is Sunny and strong. Sunny and strong, Sunny, Varam, comma, strong, and remaining all are question. So this is the only 6 hypotheses you will get as a result. So understood all of you? So only Sunny, Varam and strong is over. Sunny, Varam, okay. Understood, right, all of you? So now I will log out. So please re-log in again. So I'm going to solve the next problem. So now here you can see, if you go for length number 3, length number 3 is already present here. So now I will stop share. So please re-log in. Okay. ಎಲ್ಲ ಲಾಗಿನ್ ಆಗಿ ಆಯ್ತಾ, ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ.